called memoization. Speaking of performance, to judge how good an algorithm is, you can look at time and space complexity, so how much time or space is required to run it. This is measured in big O notation, which describes the relationship between growth of input size and number of operations needed to execute the algorithm. For example, adding 1 to every number inside an array is O of n, because the number of operations increases in a linear way as the array grows. What's relevant is not the exact number of operations, but rather the trend as the input size goes to infinity. You see, something like n factorial grows way faster than any linear function ever could, so as long as the time complexity is some kind of linear relation, it's simplified down to O of n, and the same thing goes for any other group. When writing an algorithm, there's always different approaches. A brute force approach would be to simply check every item until we find a target in a list, but if you want your program to run faster than a garden snail, you need a more sophisticated approach like divide and conquer. For example, in binary search, you repeatedly check the middle element to see on which side the target is and keep searching in that half until you find it.